Good morning, everyone. Today we are going to see through the V.PRAVEENA. V.PRAVEENA topic is the filters and fixtures. Generally, what is meant by filter? Filter is used to filter out the unwanted statement. So, in modern wireless communication systems such as mobile phones, Wi-Fi devices, Bluetooth modems, satellite communication system, and RF transceiver, generally these are operated using a high frequency radio signals, right? So, in order to process these signals effectively and efficiently, the RF building blocks are required. That is, including the resonators, filters, mixtures, etc. Now, let us see the overview of this. This unit introduces the fundamental concepts and design principles of resonators and filters, generally used for frequency selection and signal conditioning. The resonators provides frequency stability and selectivity, while the filters allow a desired signal, that is a specific signal to pass through and suppress the unwanted frequencies, right? So, unwanted frequencies and noise. And this unit also focuses on mixtures, which are very essential for frequency conversion circuits of communications receiver and transmitter. Generally, mixtures will translate the signals from one frequency to another. This enables the signal processing very easily. And let us see about various mixtures architectures, such as a passive down conversion mixtures and active down conversion mixtures, and single balanced mixtures, double balanced mixtures. These are will be discussed along with the operating principle, characteristics, advantages, and application. And understanding these components is very plays a very major role for all of transceiver design because they will directly influence the system performance, sensitivity, selectivity, power consumption, and signal quality. And what we are going to learn about in this fourth unit is that is we will gain a knowledge about the strong foundation for the analysis and design of modern wireless communication system. Okay, let us see about the resonator. What is meant by resonator? Resonator is a device, that is, it's an electrical device or a structure that stores energy and naturally oscillates at one or more specific frequencies, is known as resonant frequency. Okay, at resonance, the energy will continuously changes between electric and magnetic field with a minimal losses. The resonators are widely used in, that is, RF transceiver, oscillator, filters, frequency synthesizers, and the wireless communication system, etc. There will be the different types of resonators. That is the RC resonator. RC resonator is nothing but consists of inductor and capacitor that will be connected together. That is a RC resonator. And second is transmission line resonator. Transmission line resonator is nothing but that will uses a section of transmission line whose length is related to the signal wave. That is a transmission line resonator. And the third one is cavity resonator. Cavity resonator is nothing but it's a hollow metallic enclosure. That is, it is a hollow metallic structure that confines the electromagnetic waves and resonance at microwave frequencies. That is a concept behind cavity resonator. And fourth one is the dielectric resonator. Dielectric resonator is nothing but it is made from a high permittivity ceramic material that will trap the electromagnetic energy within itself. That is a concept behind dielectric resonator. And where it is used means it is generally the RF transceiver that is a components used in the RF transceiver mainly used for Wi-Fi router. These are the general application. Okay? We have to remember these. There's a Wi-Fi routers, mobile communication system, wireless communication system, satellite receiver, etc. Okay. Okay. Generally, the resonators are fundamental components in RF and microwave system. Then the LC resonators are suitable for low frequency application and the transmission line resonators are widely used in microwave circuits. Okay, and cavity resonators provides very high Q factor, that is a quality factor for radar and satellite system. Dielectric resonators, that offers a very compact size with excellent stability for modern wireless communication devices. Okay, that's the concept behind that. Then this is a uh, these are the types of resonator we have already seen in the previous slide itself. That is a LC resonator, transmission resonator, cavity resonator, and dielectric resonator. Then filter. The filter is an electronic circuit that is mainly it will allow the certain frequency to pass through and modulating the frequency. The filters are essential components in RF communication, audio, and signal processing systems. Okay, the filters are the filters are often built using a resonator such as LC resonator, transmission line resonator, cavity resonator, or dielectric resonator in order to achieve a high frequency selectivity. And why we are using filter? Yes, in order to remove the unwanted noises. And it will separate the communication channel. It will improve the signal quality. And it will prevent the interference. Okay, that's why we are using the filters. And there will be the different types of filter. That is a low pass filter. Low pass filter is a low frequency, and it can be a high frequency that we already know that. And high pass filter. High pass filter is nothing but it will passes a high frequency and blocks the frequency. That is a high pass. Band pass is nothing but it allows only a specific rate of frequency to pass through and rejecting a frequency below that rate. That is a band pass filter. And band stop filter is a filter that is it is a band stop filter that is called as notch filter. Okay, it rejects a specific band of frequencies while allowing the frequency above or and below the band to pass through. These are the different types of filters. Where the filters are used means that is we are using the filters in channel selection in the wireless communication systems. And it will reduce the noise, right? So that is the main concept in the filters. And these are the different types of filters. That is, we have already seen that, right? The basic filter configuration. Basic filter configuration that is a specific filter realization that is coupled resonator filter. The coupled resonator filter consists of two or more resonators that are connected, that is coupled through the magnetic coupling or capacitive coupling. Okay, that is the interaction between the resonator creates a very high selective frequency resonance. Okay, that is a concept behind coupled resonator filter. And next one is ladder filter. Ladder filter is nothing but LC filter. LC filter, that is a ladder filter is formed by connecting the inductors and capacitor in ladder-like arrangement. It is one of the most used filter structures in electronic circuits. Okay, and the mainly it will used in the high pass, low pass, band pass, and band stop filter. Okay, they next slide is combined filter. Combined filter is nothing but the resonators are shorted at one end. That is, it's a microwave band pass filter consisting of multiple resonators that are short circuit at one end and capacitively loaded at the other end. These resonators are arranged parallel to each other, resembling the teeth of a comb. And it will resemble the comb teeth like that. Okay, that is a combined filter. The main advantages is that the size will be very compact and it will that is good frequency stability and high selectivity. That is the main advantage. And second is hairpin filter. Hairpin filter is nothing but it's a planar microwave filter that made using a U-shaped microstrip resonators. And it is essentially a folded version of parallel coupled line filter. And wireless means it is used in the Wi-Fi system, Bluetooth devices, RF modules, etc. Microwave communications also used. Okay. And third is cavity filter. Cavity filter is a high performance filter that uses a metallic cavity such as resonators in order to achieve high selectivity and very low loss. And that is the main concept. That is the definition of cavity filter. And applications is that cellular or base station, satellite communication, radar system, and microwave links. Next, that is these are the application. Resonators and filters are the key components in RF and wireless communication system. These help in selecting the desired frequency and rejecting the unwanted signals and improving the overall system and performance. Okay, These are the applications that is a RF front end, oscillators, mixtures, and spectrum analyzer. Then wireless communication system. Um, Generally, these they form the foundation for efficient RF and microwave system design. These are the applications. Okay. Then special filter realization. Special filter realization is nothing but it refers to the implementations of filters that go beyond basic low pass, high pass, and band pass filters. These filters are designed for the specific requirement in RF communication and signal processing systems. Okay, where the standard filters may not provide such a sufficient performance. So there are the types of specific filters. That is a coupled resonator filter, ladder filter, and combined filter, hairpin filter, cavity filter. These are the types of specific filter. First one is coupled resonator, ladder, combined, hairpin, and cavity filter. Note it down. Combined filter, that is the notch filters are that we call band reject filter. And the combined filters, I have already told that. That is a COM filter is a filter whose frequency response contains a series of that is regularly spaced peaks and nulls. And that is, it will resemble the teeth of a comb. Okay. That is the main concept of combined filter or COM filter. Okay, notch filter. Notch filter is otherwise called as band reject filter. And next, next is all pass filter. All pass filter is nothing but it allows all the frequency to pass at the same magnitude, but changes the phase of a signal as a functional frequency. That is the main concept. What are the advantages is that the amplitude distortion will be there and precise phase control. Second one is delay line filter. Delay line filter is nothing but it introduces a precise time delay to a signal before it is processed or transmitted. So what are the applications is that radar system, instrumentation, signal synchronization, and communication system. And next one is digital filter. Adaptive digital filter is nothing but adaptive filters of automatically adjust the filter coefficient according to the changes in the input signal or environment. Okay. There will be the different types of adaptive digital filter. We have already learned it in signals and systems. And TSP, right? So least mean square filter. That is LMS filter, least mean square filter. And RLS filter. RLS filter is nothing but recursive least square filter. Next is surface acoustic wave filter. So surface acoustic wave filter is nothing but it uses acoustic waves that travel along the surface of piezoelectric material, such as quartz, lithium, niobate, in order to filter the signals. The working principle is that the electrical signal will be converted to the acoustic waves by an input transducer, and acoustic waves travel along the substrate surface. And that is the output transducer converts acoustic waves back into the electrical signal. That is the main concept behind the surface acoustic filter. That is, the electrical signals will be converted to the acoustic waves by the input transducer, and the acoustic waves will be travel along the substrate surface. Output transducer that will convert the acoustic waves back into the electrical signal. That is the main concept. That is the working principle of surface acoustic wave filter. Okay. Then is crystal filter. Crystal filter uses the resonant properties of quartz crystal in order to achieve a very sharp and stable frequency selection. What is the concept? What is the working principle? Is that the quartz crystal vibrates at a resonant frequency due to the high Q factor, that is a high quality factor. It allows only a narrow band of frequencies to pass through. That is the main concept. And next is realization technique. Realization technique, that is a filter implementation. That is a filter implementation refers to the practical, that is practical realization of filters using a digital or analog techniques in order to achieve the frequency selective characteristics. First is analog realization. Analog realization is nothing but analog filters process a continuous time signals using an electronic components. That is R, L, and C elements. Okay. Next is using the operation, that is a hop-up, using operational amplifier in order to build an active filters. And third one is quartz crystal SAW devices. And by analog filters, these are the process. And for, for the digital realization, we are using a FIR and IAR filter. FIR is nothing but finite impulse response, and IAR is nothing but infinite impulse response. Okay. For the finite impulse response, it will be stable and linear phase. For IAR, it is efficient and requires a fewer computation. That is the main concept. And second one is FPGA based filters. FPGA based filters are that is implemented using a field programmable gate arrays. That it will provide a very high speed and low latency. That is the main concept. And third is adaptive filter. Okay, it will automatically adjust the filter coefficient based on the error feedback. Okay, that is the main concept. And these are the applications. That is applications. The filters are used in many electronic and communication system in order to remove the unwanted noises and to improve the quality of the signal, input signal. Okay. That is a wireless system, wireless communication system. That is a radar and sonar system. And third is biomedical application. And fourth is audio processing. These are the applications. Okay. And next is filter implementation. The filter implementations I have already told that will be using a analog or digital type of filter. And analog type of filters we are using RLC or op-amp in order to filter out the unwanted signals. Okay. And the digital filter implementation, either we are using a DSP processor, microcontroller, or FPGA. What are the types? We have already seen that, right? So here, FIR and IAR. FAR is a finite impulse response. IAR is a infinite impulse response. Where the applications, what are the applications? It is audio processing, image processing, and communication system. Why the filter implementations is important? Yes, in order to remove the noises and in order to improve the signal quality and in order to enhance system performance. That's why we are using a filter. Okay. Then filter implementation, that is analog filter. We are using a active or passive components in order to filter the continuous time signal. That is a passive component. Passive components are we have learned about passive components and active components at first year itself, right? So passive components are resistors, capacitors, and inductors. That is, example is that example RC low pass filter. It will process a low frequency and blocks a high frequency. It is mainly used in the audio circuits in order to remove the high frequency noise. Okay. Then active filter. Active filter that is uses a op-amp that is op-amps, resistors, capacitor. They not require the inductors. Active filter they not require the inductors and can provide a amplification. That is the main concept. Okay. And next is types of filter implementation. That is a digital filter. Digital filter processes discrete time signals using a mathematical algorithm. There are implemented in the software or hardware such as DSP processes, microcontroller, and FPGA. That is FIR. FIR is the finite impulse response. This filter is a digital filter whose output depends on a current and previous input signal. FIR filter is a digital filter whose output depends only on the current and previous input samples. Okay. It does not use a feedback. FIR doesn't need a feedback. Okay. This is the main concept. Okay. Then let us see the basic characteristics of mixtures. Mixture is a non-linear device. You have already learned, right? So mixture is a non-linear electronic device that will be used in RF and communication system in order to convert a low frequency or frequency into the article. That it is a essential component in transmitters and receiver. Generally, mixtures are used for up conversion. That is a modulation. The modulation is not. That is up conversion is nothing but it will be converting a low frequency signal into the high frequency signal for the transmission. And the down conversion is nothing but demodulation. That is, it will convert a high frequency signal, receiver signal, to a low frequency signal for easier processing. That is the main concept. And non-linear operation, that is, a mixture is operated using a non-linear device such as diodes, transistors, etc. And the main applications is the mobile phone, radio receiver, television receiver, etc. Right? Frequency conversion. Frequency conversion, for example, The frequency conversions is a process of changing the signal from one frequency to the another using a mixture. It is widely used in RF transmitters and receiver. That is, it's the input, that is a RF signal that will be transmitted or received. That is, the LO signal is nothing but local oscillator signal. It will be locally generated reference signal. That is the output from the mixture. Okay. Then what are the types of mixtures? Up conversion. Up conversion converts a low frequency into the high frequency signal, and down conversion converts a high frequency into the low frequency signal. And unbalanced mixture. Unbalanced mixture, it is widely used in, that is a simple or low cost communication cycle. We are using an unbalanced mixture. Single balanced mixture. Single balanced mixture is nothing but that will suppresses both RF and LO leakage. That is a radio frequency and local oscillator leakage. Okay, it is widely used in a RF system, and that is the main concept. And conversion laws and conversion laws are key. Conversion laws are again, that is it is a ratio. The conversion laws is nothing but it is a ratio of, it is a loss of signal power when a passive mixture converts one frequency to the another. Okay, it is a ratio of RF input power to the RF IF output power. It is measured generally expressed in terms of dB, that is a decibel, and conversion gain for the active mixture, that is output power will be greater due to the amplification. What is the use of amplifier? Yeah. Amplifier leads, right? So, isolation. Isolation is nothing but it is the ability of a mixture to keep the RF, that is a radio frequency, local oscillator frequency, and IF signals in order to separate from each other. That is isolation. That is the main concept. And linearity and intermodulation. Linearity and intermodulation. That is, a linearity is the ability of a mixture in order to produce a desired output frequency, but without creating an unwanted signal. In order to produce a desired output frequency without creating a unwanted signal. That is the concept of linearity. And what is meant by intermodulation? Intermodulation is nothing but that is when a strong signal will enter into the mixture means some additional frequencies will be added. That is called the intermodulation products may be generated. In that time, the intermodulation products will be generated. Okay. And noise figure. Noise figure is nothing but that indicates how much extra noise a mixture adds to a signal during a frequency conversion. That is a noise figure. If the noise figure is very low, that indicates that better to simple performance. And port matching. Port matching is nothing but that will matches the impedance of RF, LO, and IO ports to the system impedance. Okay, why it is important, Aptina? If impedances are not matched, that will result in that signal reflections will occur. The maximum power will not be delivered to the receiver, and the power will be lost. The system performance, overall system performance will be decreases. That is a disadvantages of if the impedance are not matched, that will be results in that. Okay. Next is passive down conversion mixture. Passive down conversion mixture is nothing but it's a mixture that uses a passive nonlinear components such as a diode, MOSFET switches in order to convert a high frequency RF signal to the lower intermediate signal. Okay. Okay. This is a block diagram. It is a RF signal is the incoming signal that is received from the antenna, and it will contains the information that we need to process. Okay. Then the local oscillator, that is the LO signal, is nothing but local oscillator signal. It will generate a stable frequency inside the receiver. That is a local oscillator is used to shift the RF signal to a lower frequency. Okay. Then mixture. What is the use of mixture? It will done combines the RF and LO signals. It uses a passive device that is diodes or MOSFET switches. No amplification is provided. So it is called a passive shift. And high F output, that is an intermediate frequency output. Intermediate frequency output. The mixture will produces a new frequency, that is some frequency is nothing but RF plus LO, that is radio frequency plus local oscillator frequency, and difference frequency is nothing but RF minus LO, that is RF frequency minus local oscillator frequency. Usually, the receiver selects a difference frequency, that is called an intermediate frequency. Okay, that is IF. That is the main concept. And where it is used means it will use in the mobile phone receiver, Wi-Fi receiver, radio receiver, etc. And this is a concept I have already explained in the block diagram itself, right? So these are the application that is RF receiver, that is super heterodyne receiver. And these are the application. Sorry for the interruption. Active now conversion machine. Active now conversion machine is nothing but it will perform a frequency conversion with a gain. That is, it will convert a high frequency RF signal into the low frequency intermediate frequency signals for easier processing. And RF receiver, that is a super heterodyne receiver. What is the purpose of super heterodyne receiver is that it will convert the received order signal into the higher signal. That is a concept. Okay, spectrum analyzer. Spectrum analyzer is nothing but it will shift high frequency signals to the low frequency signal for the analysis. Okay, that is a concept. And radar front end. Radar front end is to convert a received radio echoes to the higher signal. Then satellite communication system. Satellite, what is the purpose means it will convert the high frequency satellite signal into the low frequency signals. That is a concept. And next is these are the application. These are the active tone conversion method that will convert the high frequency signal, that is high frequency RF signal into the low intermediate frequency IF signal for AC processing. That is it's used in RF receiver, that is a super heterodyne receiver, spectrum analyzer, and radar front end satellite communication system. These are the application. Then this is a block diagram. That is here, the RF signal is an incoming signal that is received from the antenna. It contains the information that needs to be processed. Okay. The LO signal is nothing but local oscillator signal. Local oscillator will generally generate a stable frequency inside the receiver. It is used to shift the RF signal to the low frequency. The passive mixture. Passive mixture is nothing but the mixture will uses passive nonlinear devices such as devices or MOSFET switches. It multiplies the RF signal and LO signal, that is a local RF radio frequency signals and local oscillator signal. Because of the nonlinear operation, the new frequencies are being generated. And IF output, that is the filter, will remove the unwanted frequency. That is the only difference frequency is selected as a IF signal. That is the main concept here. Why we are using IF is IF signal, that is intermediate signal, is easier to amplify, filter, process. Okay, that will improve the receiver performance and reduces the circuit complexity. That is the main concept. And I have already explained that in block diagram itself. So, and these are the application that is we are using it in mobile transceiver, low power RF receiver, software design radios, wireless LAN, and Bluetooth. This will mainly convert the RF signals into lower IF signals for processing. So low power RF receivers are being up. So what is the purpose means it will receive a weaker radio frequency signals while consuming the less power. And the STR is nothing but software defined radios. What is the purpose means it will convert the RF signals into the digital signals that can be processed by the software. Then single balanced. Single balanced is nothing but it will consist of one pair of diodes or transistor. That is, it is a mixture in which one input signal is balanced, that is a differential, and other input signal is unbalanced. That is, one is balanced and one is differential. That is, one is unbalanced. Usually, local oscillator input is balanced. Okay, while the RF input is unbalanced. The mixture is commonly built using a pair of diodes or resistors. Okay? That is a concept. And these are used in the radio, receiver, mobile communication system, etc. And this is uh, in the block diagram itself, that is IF, RF signal will be the input signal and it will be combined with the LO signal. The mixture will done that process. So at that output, we will receive the higher signal. That is a difference of RF, that is a radio frequency, and local oscillator signal. That is, it partially suppresses the local oscillator signal from appearing at the output. These are the advantages. It is very cheaper and simpler than the double balanced mixtures. It is better than the unbalanced mixture in terms of elbow leakage. That is it is simple in design, and it uses a fewer components and is easy to implement, and it is a low cost. It will reduce the elbow leakage. And these are the application. So it will be used in the radio receiver, mobile communication system, RF receiver, wireless communication systems. Okay. Then these are the disadvantages. Among the disadvantages also there, that is incomplete suppression. That is fully the elbow leakage is not fully suppressed. The incomplete suppression of elbow leakage will be there, and incomplete suppressions of RF, that is a radio frequency will be also there, and moderate isolation between RF, LO, and diodes. Okay. Then is double balanced mixture. That is a double balanced mixture. Double balanced mixture is that is RF and that is it's an advanced mixture that suppresses both RF and LO signals from appearing at the output. Okay, it is usually implemented using that is a four diodes in a ring configuration. That is a diode ring mixture of four transistors. That is four diodes of four transistors. Both the RF and LO outputs are balanced. It will be differential. In order to create a balanced signal, the transformers of balance are used at both the RF and LO input ports. And this is a function. That is a here we are using a four diodes of four transistors. The LO, that is working principle is that the RF and LO signals are applied as balanced inputs. The mixture will multiply the two signals and produces a sum frequency, difference frequency. The filter selects the desired IF signal. So that is a working principle. What are the advantages that excellent, that is, LV suppressions will be excellent here compared to the single input. So high put isolation and better linearity. What are the applications of that? Mobile communication system, radar system, etc. And that is, and double balanced mixture is a high performance mixture. Okay, it uses a four diodes. This is a concept you have to remind. Okay, due to the balanced structures, it strongly suppresses the LO leakage because we are using four diode, right? So due to the balance structures, it strongly suppresses the LO leakage, RF leakage, and even order harmonics. Okay. Then these are the disadvantages. It will be very more complex in structures, and compared to the LO suppressions, it will be better. So that is the advantage, and it requires more LO drive power. That is a disadvantage. Okay. Applications that single balanced mixtures will be used in low cost areas, and double balanced mixtures will be used in radar and communication system. Thank you.